Hey guys, Nick here from EP Automotive, and as promised, this is going to be my first 3D modeling video. And coincidentally, well, maybe not coincidentally, it actually doesn't have really anything to do with cars or drifting or anything like that. Now, I have 3D printed some stuff for cars. There's a decent amount of car parts that you can print, really depending on what exactly you want. Obviously, you're printing relatively brittle plastic, so probably nothing that's going to sit on the outside of your car or anything, but it's certainly possible. It's just, case by case. If we're able to design it and produce it, we will. If not, then you're just going to have to find it somewhere else. But anyway, what I wanted to go over today is actually a project I started very recently, just a few days ago. And a project that's probably going to continue on for, I don't know, a couple months, just because it's not at the top of my list, and I want to keep iterating on it and improving it until it is exactly what I would like. So you might be confused by the design that is on your screen right now. I'm using Autodesk AutoCAD 2020 to kind of mock up what I'm going to be making so that I'm not just designing pieces in Fusion 360 and you're wondering what in the world this is all going to become part of. So let me switch over to Google Chrome real quick. Got screenshots here, pictures of the Ender 5 Pro, which is the printer that I use. And the reason I'm showing this to you is I wanted to kind of show what part of this printer is in AutoCAD right now. So I am mocking up the front of this printer. The reason is I'm going to be building a custom enclosure, and I'm basically going to be making brackets that are going to sit and screw into these aluminum extrusions that are part of the printer frame. And then they're going to have small brackets that come off the side that you're going to be able to slip a 1/8 inch piece of acrylic into. So it's basically going to provide brackets to slip an acrylic piece into, and the acrylic is going to provide the walls for each side of this printer. Enclosures are pretty great for 3D printing for a variety of reasons. I mostly print PLA, so the enclosure is not really like necessary to actually do the print. Whereas ABS, you probably want an enclosure just to keep temperature differences out of the actual print area, as well as keep the heat up in the print area, since ABS is more sensitive to those temperature changes than PLA is. But the enclosure for me, really, since I mostly do PLA, is just for aesthetics and also to keep dust or any other particles or anything from going into the printer. I also recently moved the printer to a different room. My cat hangs out in that room more than really anybody else does, so I would like to keep her from messing with the printer as well. So the enclosure is going to be pretty good. But here's one angle of it. Here's another angle of it. Basically, what we're looking at is these aluminum extrusions that basically form the frame of the printer. And if you're familiar with aluminum extrusions, you'll know that there's these rails that are kind of set into the extrusion, into the metal. And inside those rails is what you can screw things to. So there's these little T-nuts that slip inside of there that are threaded that you then bolt to, and the T-nut kind of clamps to the inside of this rail, and then your screw or your bolt is going to pull your piece to that rail and hold it steady. So I am going to be designing brackets that with holes that are going to be able to bolt straight into these rails inside the extrusions. So aluminum extrusions are pretty great for like modularly building things, which is probably why Creality chose to go with this design for the Ender 5. I think really all of their printers use this, and tons of other 3D printers use these kind of frames too. So back to AutoCAD. So this might make a little more sense now. What I've done is I have created these two aluminum extrusions from the 3D printer frame, and I have made them red. You'll see these lines in here. Obviously, our line on the left side, this is going to be, the flat piece, and here's going to be the flat piece. Over here is going to be the flat piece, and then these sections in between, each of them is going to be the rail, the inner rail for the where we're going to bolt to. So if you want to look at that again, it looks like this, and back in AutoCAD it looks like this. So this is going to kind of help us mock it up a little bit and show you what the end result is going to be. So as you can see, I've added a couple other drawings to this AutoCAD drawing. The pieces that are in white are going to be the brackets themselves. So basically they are going to sit on the extrusion. We're going to bolt them in to these rails that I just described, and then they're going to have this flange that comes off here. And inside of that flange is a little slit that it's an 1/8 inch wide, and then the acrylic sheet can slide right in there. So ultimately, I'm probably going to build at least one more for each side to support it on the sides, possibly one at the top to support it on the top. But the idea is that this sheet can be slid in and out of these brackets. So hopefully that gives you an idea of what the end result is going to look like. And without further ado, we'll jump over to Fusion 360 and check out the completed part. So this is the completed model that I just made the other day, and again, based on our AutoCAD discussion and the design of this thing just now, this should make a little bit more sense. But basically, we've got this bracket where it's going to sit against the extrusion, and we're going to put 4 bolts in there. Now, if you're wondering about what's going on under here, the reason it's like this is if we go back to the Ender 5 and look, we've actually got some stuff going on here. So if your printer is set up, if you built it according to the instruction manual, you're going to have this kind of this control module that protrudes from the extrusion. So you're going to have a few millimeters that you're going to need to kind of compensate for because it's not flat all the way down. Same thing kind of over here. You've got this little nub that comes out kind of as like a plastic little stop if it's up against a wall or something. And that's not quite as far out as the control panel, but it's a few millimeters. So what we did was I measured it. It's between 3 and 5 millimeters. It was kind of hard to get a good measurement of where this control panel kind of stops at from the extrusion. So I ended up just kind of going with a 5 millimeter gap down here so that basically this back piece is going to lay flat against the frame of the printer, and then this is going to kind of go over anything that protrudes out from the bottom of the printer. So it's 5 millimeters, so it's not very, very big at all. And it is going to move the plexiglass sheet out 5 millimeters from the front of the printer, so it's not going to be 100% flush with the frame, but that's okay. You know, the thing still needs airflow, so being able to pull air in around that small 5 millimeter gap is going to be probably good. So that is the piece. We will go ahead and step by step recreate it over here in the blank Fusion 360 project that I've created. Now I'm going to pretty frequently make references back over to this for measurements, like exact measurements and stuff, just because I had all this written down on a sheet of paper, and I made small changes to it kind of as I went along and didn't really record those changes on the paper. So I'm not going to be able to, you know, like right from scratch make this thing again, but I'll just make a couple of references over to here if I need to. So the things that we know about our printer based on measurements that I took, and if you're going to do the same thing, you should take your own measurements, even if you have the same printer. There's probably not going to be very many differences, but if there are, that would be not great. So basically what we know about our printer is the frame, the extrusions, are 41 millimeters wide. I have just added them as 400 millimeters tall, which I'm not able to get a good, 400 millimeters tall. But we don't really care about that a lot. You know, we're going to be making 4 or 5 or 6 independent brackets that can slide up and down these rails, you know, any way that you want them to. So we don't really care about how tall this thing is. Really what we care about is the width, because the bracket's going to go the full width. We care about where the rails are, where our little bolt, you know, holes are in these rails that we can stick our T-nuts, and we care about how far out these flanges are going to come, what the little what would you call that? Slit's maybe not the greatest word, but this little kind of drop-in area in here for the acrylic. So again, we don't really care about the height of these rails. We don't care really about a ton of like the construction of the printer other than the width of the rail. So we're looking at 41 millimeters. And let me see here. Let me go back to the picture one second because there's one more measurement that I had. So this control panel, if you look at this plate where it bolts on, from the top to the bottom of here is about 1 1/4 inches. From the top of the plate down to the top of this rail down here, the bottom part of the frame is about 1 1/4 inches. So I wanted I wanted the bracket flange to kind of sit almost even with the top of this rail, maybe even just a little bit below it. So basically what I've done is added 1.25 inches to the bottom of that bracket. So if we go back to Fusion 360, this guy, if we inspect, this guy right here should be 31.75 millimeters, which is 1.25 inches. So basically, oh, my headset just gave me a battery low notification, so we'll see how long this lasts. But basically, this part where it kind of comes up, this is going to sit flat against the control panel of the printer right here at the top, and then it's going to drop down 1.25 inches with this, and it's going to come out. So those are our measurements. So we know it's 41 millimeters wide. We want to probably do, I think 82 millimeters tall. Yeah, so I did 82 millimeters for our main bracket here. So to start out with Fusion 360, and here comes the disclaimer. I'm a computer science engineer. I'm a programmer as a career. I am not a mechanical engineer. I am not a professional CAD user by any means. In college, I hung out with a lot of mechanical engineers. I did pick up a little bit of CAD experience, and obviously, if you have the software and enough time, anybody really is able to kind of learn, the ins and outs of a piece of software like this. So, if you are watching this video and I say something that is not entirely accurate, or a process that I'm doing is not really, airtight engineering-wise, leave a comment if you want. Please don't be hurtful, because I truly am confessing to you now I am not a professional with CAD. The things that I make are designed really for my 3D printer. They're designed for, if I've got like a buddy or a hookup with a CNC or anything like that, the things that I design are going to be designed to be used by me. So, and used by the things that I use to make these pieces. So they work. All of the things that I've ever made here have worked, with my printer, the processes that I use and the things that I build. But again, if it's not airtight engineering, I apologize. So we're always learning, and I hope to get better at this kind of stuff in the future and as time goes on. So anyway, Fusion 360, we'll start out with a blank canvas here. And basically the way that I always do things is I sketch it out, and then I kind of proceed to make it solid. So we'll start with a sketch, a two-dimensional sketch. Select really any plane. I usually just select, the flat plane that's already there. And we said something along the lines of 82 millimeters long for our piece, and we know it's going to be 41 millimeters wide. So we're just going to start our rectangle, and it's going to let you, without holding down your mouse button at all, it's going to let you drag this. And you'll see these numbers here. There's a number on the left, there's a number on the bottom. Those are going to be your dimensions of the rectangle. And here is where any kind of CAD software really is extremely helpful, because you could really do 3D modeling of sorts in most programs, maybe even Photoshop if you wanted. But this is going to give you really exact measurements and ensure that everything is like spot on. So in order to do that, in order to give the exact measurements that we want and not have to drag this to our exact numbers, you'll see how the one on the left is already highlighted. So that's going to give us actually an input to type in. So we're just going to type 41 because our units are in millimeters. We know that the extrusion is 41 millimeters wide. So we're going to type 41. We're not going to hit enter. We're not going to hit escape. We're not going to do anything like that because we're not done. We're going to hit tab to tab over to our next input for the length of our sketch. And we said that was going to be 82 millimeters. So now that you've got 41 in width and 82 length, you're going to hit enter, and that's going to give you a 41 millimeter wide piece with 82, or wide sketch with 82 millimeters long. So the next thing that we need to do is give this thing some depth, make it 3D. If we look at it right now, there's nothing really 3D about this. It's 2D plane. So the best way to do this, at least in my experience, is to use the push-pull tool or extrude tool, like so. Now, the question is, how thick do we want this bracket to be? I can't actually remember exactly what thickness I used for it, so we'll look here. We used 12 millimeters. Now, the reason, I actually do remember this now, I started out with 10 millimeters and was concerned about how thick some of these walls would be once you get down to this flange. So I decided to increase it from 10 millimeters to 12 millimeters. And the reason is, remember how I said we need to drop this down, or drop this up for the control panel, 5 millimeters. Once we drop this, we're working with the number of the thickness in millimeters here minus 5 millimeters. So back when I had this piece here as a 10 millimeter thick piece, we were losing 5 millimeters here with the drop up, and that was making this total thickness here 5 millimeters, which if we move around here and look, basically once you take away the 1/8 of an inch filling in here, these walls were going to be way too small. They were going to be just under 1 millimeter. And I thought that, one, I don't think the 3D printer's resolution is going to print that very well. And two, even if it did, I have a feeling that over time these things would probably crack. So I ended up adding 2 millimeters to the total thickness of this bracket. And that ended up bringing these walls to just under 2 millimeters instead of just under 1 millimeter. So I figured with just under, it's like 1.91, I think, just under 2 millimeters of thickness there, I think that should hold up a lot better. So that is the reason that we did that as 12. So basically what we're going to come over, bounce back over to our other project, our new project, back over to the solid tab, hit extrude. Now we're going to pull this up 12 millimeters. We're just going to type in 12, hit enter, and bam, there we go. Now we've got a nice rectangular block there, solid block. It's going to be 41 millimeters wide, 82 millimeters long, and it is going to be 12 millimeters thick. So now that we've got that, this block here is going to essentially be this first white block on the top of our bracket. So this is going to be the piece that the bottom part meets the control panel. So we have a couple options here. We could continue making the rest of the bracket, or we could drill holes. I'm going to go ahead and continue making the rest of the bracket before we drill the holes. So again, we're going to make the bracket for the right side of the printer. So we're just going to need to have our flange come off the left side of this bracket. So it's in the center of the printer. So the next thing we're going to do is we're going to create another sketch. Always create more sketches. Now, this is where, you know how I mentioned the lack of airtight engineering and lack of actual, Fusion 360 training. This is probably where it's going to show itself. So I'm going to go ahead and select just the piece that we already are working on. We're going to draw another rectangle, of course. And what did I say? We're going to drop that down 1 1/4 inches, which is 31.75 millimeters. So in order to do that, we are basically going to, so we're going to make it 41 millimeters wide like the existing piece, and we're going to make it 31.75 millimeters long. It's going to give us our drop down. Now we need to extrude this 7 millimeters. 7 minus 12, or sorry, 12 minus 7 is 5. So we're going to grab this guy. Now, you'll notice that if I choose to extrude up, extrude by a positive number of millimeters, we're actually not doing at all what we're supposed to be doing. So the reason for that is because of the plane that I have selected to create the sketch on. So for this specific application, we need to go down by 7 millimeters. So we're going to type in -7, hit enter, and that's going to give us kind of this offshoot from the main piece. So if we go up to inspect, click on this line here, it should say 5 millimeters. Perfect. All right. Now we need to add the flange to the piece. So we've added our kind of drop down here, or drop up here. Now we just need to add a flange that comes off this side. So we'll bump back over here just for reference and see what's going on here. Now let's see what height or what dimensions I used on this piece. 20 millimeters, and the inner portion here is 16.825. So that should, okay. So we made this 20 millimeters. I can't remember exactly why, maybe it was just a nice round number. So basically we want a 20 millimeter flange that's going to kind of jut off this drop up here. So good old sketch tool once again, select the same plane. We're going to be coming off this side right here, I think, because we're going to come off this side. So basically take your rectangle, start at the corner, and we made it 20 millimeters by, how many inches did we come out? Or how many millimeters did we come out? 50. We came out 50 millimeters, so let's do that. 50 long by 20 wide. There we go. Now, solid extrude, good old extrude, click that. Go ahead and type -7, yep, -7. Hit enter, grab your rotate tool, and look at that. Wow, look at our bracket. Nice, nice, nice. All right, so let's go ahead and push this in so that we can get our piece of acrylic in there, and then we'll go ahead and drill the holes. So as you can see, the way that this is set up is so that the acrylic can slide in here. It's about, I think it's about a ½ inch out from the, yeah, it's a ½ inch out from the extrusion. So this little wall right here is going to be a ½ inch. And then right in here, you see it's going to slip in, and then it's able to, come all the way out. So this part's open right here. So the acrylic we know is 1/8 inch thick. So if we take our inspect tool and kind of look, what is that in millimeters? I already did this once. So 3.175 millimeters. Let me just double check that. 3.175. Yep, looks accurate to me. Let's triple check it. Yep, that is accurate. So 3.175 millimeters is going to be 1/8 inch. So that's the goal that we're going for here. And then our, I believe that our walls are going to be, yep, 1.913 millimeters. So getting this centered, getting it, let me, one more measurement we got to do is this guy right here. What is a ½ inch to millimeters? 12.7. So let's verify that this is 12.7. If we just do an inspect, 50 millimeters, 37.3 millimeters. Yep, that is going to be 12.7. Perfect. So in order to do that, sketches are my best friend. They might be your best friend, who really knows. I'm going to basically make a new sketch on this face here. I'm just going to take a line. I'm just going to do right out here 12.7 millimeters. All right. Oops. Yeah, another line. 12.7. Okay. Now we need to, we know that 1/8 inch was, what did I say that was? 3.175 millimeters. So if we know that 1/8 inch is 3.175 millimeters, okay, we know that the thickness of this face is 7 millimeters. So if we take our calculator again, and we do 7 millimeters minus 3.175 millimeters, we're left with 3.825. And since we're putting this this indent kind of deal in the center of the piece, we need to divide this by 2 to figure out what each wall height is going to be, and that's going to give us 1.1925. So in order to determine where the walls stop at, I'm going to take a line and do 1.9125, okay? And then another line from the bottom here, 1.9125, okay? So now we can basically just take our rectangle tool. We're going to start at either of these points that we just created with the line, okay? Drag up and then drag out. And then you'll see that on the left, our one measurement on one side is 3.175 millimeters. Our measurement on the other side is 37.3. So we're going to go ahead and create the sketch. All right. Now we're going to come back to the extrude. We're going to click on this face, and then if we extrude it inward like so, you'll see that we're creating that indent. So we want to figure out how deep this needs to go, and then how much of a wall we kind of want on the bottom. So let's see what I had done over here. Like I said, a lot of these numbers were just kind of on a whim. So okay, inspect, 20 millimeters minus 16.825 gave us 3.175. Yep, okay, that makes sense. So we're putting 1/8 inch wall down here. So let's, oops, Control Z, I backed out of that. All right, we're going to go ahead and extrude that. And we know, what did I say this was, 20 millimeters? So basically, we want to go in 16.875, right? So negative 16.875. Enter. All right, now we've got our little slot. That's a better word for it, slot. There we go. All right, so we've got our little slot for the acrylic sheet to slide into. So, basically, what you've probably gathered from me so far is that I really like making sketches. The sketches really help me kind of get things positioned just perfectly. There very well may have been a better way to position this slot in the center of this flange here, but that is the way that I did it with the sketches. If you are wondering where your sketches went, or if you kind of do like a solid operation like this, and then all of a sudden they disappear, this took me probably a week to figure out, but they're actually all right in this folder here. So if you look, they're actually all hidden. So if you want your sketches back, you just kind of unhide them, and you'll see where they're all at. So this is going to become useful here in a second, and I'll show you why. So the next and final thing that we need to do here, and hopefully my headset doesn't die. It gave me a low battery warning probably 10 minutes ago. But the last thing that we need to do here is create our holes. So really the most important thing is obviously that the holes are going to line up with our kind of slotted rail here, so that with the T-nuts in it. So the T-nuts that I use, I actually print plastic T-nuts, and the ones that I use are an M3 like thread and diameter and all that. So I use M3 screws with them. M3 screws are, I think, 3 millimeters in diameter. So, where was I going with that? Sorry. So basically, we're going to be making 3 millimeter holes here, and the only thing that we need to make sure is that the screw is obviously going to drop right into the center of this rail. So we know that the rail is, what did I say, 7 millimeters? Yeah, we know that the rail is a 7 millimeter wide. So we just need to find the center of 7 millimeters, which is 3.5 millimeters. So we'll start by making another sketch. We'll start by putting it on this face. This is going to be real easy. We're just going to go ahead and kind of sketch this up. So I'm going to go and just make a 92 millimeter long line here, and I'll show you why here in a second. All right, we're going to go ahead and make a 92 millimeter long line here. All right, and then we should be able to do 46 is half of 92, so we'll do 46. All right, 46. So basically what I've done is just kind of divided this up into two sections first. So all that we really know is that there's going to be 2 holes in this section, and there's going to be 2 holes in this section. In fact, I should probably just seal this off to show you that it's going to be this section and this section. So now we know that in this first section there's going to be a hole somewhere over here and a hole somewhere over here. So in order to do that, let's see, we'll select our line tool again, and we know that, so this edge is going to be one edge of the frame of the printer. This edge is going to be the other edge of the frame of the printer. So we're going to come in 7 millimeters, and then we're going to know after that 7 millimeters is where our inner rail, our rail to bolt to, is at, and then we know that's 7 millimeters. So we'll start out, bring this in 7, okay, and then just bring that down 46. So now we've got one section made out here. We're going to go 7 more millimeters, and then we're going to bring this section down again. Okay, so now we know that one bolt, or one hole, is going to go right in here. Where at in here? Well, let's take half of 46. That's 23. Okay, maybe if I did that right. 23. All right. And then, oops, I probably actually, let me undo that real quick. Let me put the line right here. So we're at 23 millimeters. Oh, come on, really? Okay. And then we're going to do from the 23 in, we're going to go 3.5. So that's going to give us, on this dot is where we place our first hole, okay? So we're going to do the same thing over here. We're going to come down, or sorry, we're going to come in 7 millimeters. We're going to come down all the way. We're going to half that, or sorry, nope, we're going to go some out 7 again. Sorry, to make our inner rail portion. Come down. So this is going to be our inner rail right here. So then we're going to come in 23, and we're going to come out, oops, in 23, and then we're going to come out 3.5. So we're going to put a hole here and a hole here. Great. So let's do the exact same thing down here on the bottom. And we can conveniently use some of these measurements that we already have, some of these lines that we already have with snapping to points. So we're going to just draw this line down. We're going to take another, just draw this line down. Okay. And then do the same thing over here. Beautiful. Okay, so come in, half that to 23. Perfect. 3.5. Beautiful. Right in here, 23. 3.5. Perfect. All right, so we've got our locations for 4 holes. 1, 2, 3, 4. They are going to line up perfectly with the inner rail portion. You're going to be able to just throw a screw right through there, hook it up to your T-nut, screw it into the T-nut, and you're good to go. So now, how do we make the holes? Extremely simple. Bump over to the solid tab again and click on the hole tool. All right, now here's the important part. Rotate your face so that you can see all of your little dots, all your little points for these perfectly. Hover over a point, very, very carefully, get your cursor right into the center there. When you're ready to place the hole, simply click. It's going to put a giant hole, and we're going to edit that. So remember how I said M3 screws were 3 millimeters in diameter? So we're going to hit 3 for our hole diameter. Basically, this hole context menu over here will show you kind of each measurement. So right here, the bottom, our opening of the hole is going to be 3 millimeters. The height doesn't really matter. It just needs to be taller than our, or taller or as tall as our thickness of our piece, which we said was 12 millimeters. So we're just going to leave that as 30. Not really going to hurt anything. Then we're going to change the drill point, because obviously this says angle, which doesn't really matter, but just for like maybe completeness or maybe at best engineering practice, we're going to go and choose flat. So it's just going to drill flat hole straight through there, or not even drill. It's just going to print a hole straight through there. Click OK. Oh no! Now look, all of our sketches went away. Remember how I said this? The sketch view is going to come in handy later. The first time this ever happened to me, I freaked out because I spent a ton of time making a bunch of sketches, made the hole, and then it was just all gone. And I thought I had to just repeat the sketch process, which was really annoying. But you don't. All you have to do is come over here to your sketches and show them again. So we're back, create another hole, and we're just going to do this exact same thing on this next point. Now that we've modified our hole settings, you're going to notice that they're the same. So we can just click OK without modifying anything else. Our sketch is not going to disappear this time. So a hole tool again on our third point, and click OK. And finally, the last point. And click OK. Now you can hide the sketch again to see your completed piece. And as you'll see, our holes go all the way through the piece. They are pretty well centered. I mean, they line up perfectly. And if our math has been done correctly and my manual hand measurements of the printer have been taken correctly, this should lay right on an aluminum extrusion, and bolts should slip right through here. M3 bolts should slip right through there to a T-nut, which resides in the extrusion. So that is it. I'm actually kind of proud of this because I didn't know that if I was going to be able to efficiently recreate this on camera. This is the first take and first video, so I think we did a pretty good job here, guys. So that's that. That is one bracket. Basically, we're going to do the exact same thing for the other side. We're just going to make the flange come off the right instead of the left. The exact same, dimensions and everything. The things that I haven't yet designed are the brackets that are going to hold or support the acrylic sheet as it goes up the printer frame. So probably going to have some new stuff for that eventually, which would be kind of cool to talk about since this bracket's pretty much the same as this one. So yeah, that is it. If you guys have Ender 5, I'm not sure if the Ender 5 and the Ender 5 Pro are the same frame-wise, but I have the Ender 5 Pro. The frame is like this, like I had shown you. These brackets will in fact work with the Ender 5 Pro. So once they are all complete and I've tested them out and made sure that it all works, I will probably throw them up on Thingiverse or like a Dropbox or Google Drive link or something like that. So if you guys have that printer and want to use them, hopefully eventually when I have time to continue working on the project and finish it up, hopefully we'll have a really cool and very simple modular way to add an enclosure to an Ender 5 3D printer. So that is it. Hope you guys enjoyed the video. Feel free to let me know if I need to improve on anything, if you think this video was well done or poorly done. I would love to hear your feedback. Also ideas if you want to see anything created. If you really like my hillbilly engineering style, where I just kind of hack things together, but they do in fact end up working. If you want to see me put something together for you, or you have a request, you don't know how to do 3D modeling and want something made, I can probably try to whip it up for you. It would certainly be an adventure. So, thanks for watching, guys. I'll talk to you next time.